In 2007, an astronomer uncovered a signal that should not exist. It had reached Earth years earlier, in 2001, buried inside a folder of old telescope data. Nobody had been looking. Nobody had even noticed it was there. But when a young student finally opened that file, the pulse hit the screen like a fingerprint from nowhere. It lasted just 5 milliseconds. Then it was gone. 5 milliseconds, the time it takes your eyes to blink. But the energy behind it was staggering. It had traveled nearly 3 billion light years to reach us. 3 billion. And in that single instant, it released more energy than our sun produces in an entire day. This was the birth of one of modern astronomy's greatest mysteries, the fast radio burst. For 50 years, something has been screaming at us from across the universe. And for most of that time, we had no idea what was sending the message. Before we get to the signal itself, you need to understand what you're actually looking at. A fast radio burst is a flash of radio energy so brief that it almost slips past our instruments entirely. Most last only a few milliseconds, a sliver of time, shorter than a heartbeat. Yet in that flash, they carry as much energy as the sun puts out in an entire day. Think about that. The sun has been burning for 4.5 billion years. And in 5 milliseconds, something out there matched a day of its output. For decades, these bursts were dismissed as noise, interference, even malfunctions. It took science a very long time to admit that the signal was real. And that hesitation almost cost us everything. The story begins in 2007 with a man named Duncan Lorimer. Lorimer was a radio astronomer at West Virginia University. One day, he asked his student, David Narkevic, to dig through old data from the Parkes Observatory in Australia. The data was from 2001, 6 years old, practically ancient in science terms. Nobody expected anything interesting. It was a routine search for radio pulses in the sky. Then, buried in the noise, Narkevic found something that made him stop. A single, powerful pulse. Detected once, never repeated. Lorimer checked it, rechecked it, ran every test he could think of. And in 2007, they published it, a millisecond flash of radio energy from 3 billion light years away. The scientific community responded with a single question. Are you sure? Some astronomers argued it must be a glitch in the telescope. Others blamed a thunderstorm. Even Lorimer himself was not entirely certain what he had found. The signal was so strange that no one dared to call it real. And so, the mystery sat, quiet, ignored, for years. Because here is the uncomfortable truth about science. We only see what we are willing to believe. But then, in 2011, it happened again. Another burst. Then another. This time, the signals were caught live by telescopes. There was no denying them. Suddenly, scientists had to admit it. Something in the universe was sending pulses, and we had no idea what. The mystery now had a name. Fast radio bursts. FRBs. But naming something is not the same as understanding it. And the deeper scientists dug, the stranger the signals became. There's another layer to the strangeness. The pulse arrived chirped, high frequencies first, low frequencies later. That chirp happens because radio waves slow down slightly as they pass through gas and dust across millions of light years. It's like throwing a rock into a lake and reading the ripples to count how far it traveled. The longer the delay, the farther the burst. And this one was billions of light years away. In 2012, a telescope in Puerto Rico found something that broke every assumption. A burst that repeated. The same source, sending pulse after pulse. It was named FRB 121102, and it refused to be a one-time event. This was the first proof that whatever was sending these signals was still there, still active. But it also raised a terrifying possibility. If the source could repeat, could it be something with a purpose? Before we go there, let's look at what we've actually learned. Because the answer is stranger than sci-fi. The real breakthrough came in 2017, when a telescope called CHIME was turned on in Canada. CHIME stands for the Canadian Hydrogen Intensity Mapping Experiment. It has no moving parts. It doesn't turn. It just stares at the sky, forever. Yet on its very first day of operation, it caught a fast radio burst almost immediately. Astronomers were stunned. The telescope wasn't even finished calibrating. And from that moment, the floodgates opened. Where scientists had found a handful of bursts in a decade, CHIME found dozens in a single year. Today, we've cataloged thousands of them. And the more we found, the more we realized how little we understood. Some bursts repeat. Most don't. Some seem random. Others follow a schedule. In 2020, scientists announced that one repeating source pulses every 16.35 days. For 16 days, silence. Then, for a few hours, it fires again. Whatever is sending these signals is behaving like a machine, or an orbit, or both. That level of order, in a universe of chaos, is not supposed to happen. So what is doing this? Scientists have proposed neutron stars, black holes, and even collapsing alien civilizations. But there's one theory that refuses to die. The theory that the signals might be artificial. It was the first thought astronomers had, and it's never fully gone away. In fact, the very first pulse Lorimer found was almost labeled LGM, Little Green Men. The name was a joke. The fear behind it was real. Because if someone, or something, is broadcasting, we have no way to know what they want. But before you imagine spaceships, hear the full picture. In April 2020, a fast radio burst was detected inside our own galaxy for the very first time. It came from a magnetar, a neutron star with a magnetic field a trillion times stronger than Earth's. The object is called SGR 1935 plus 2154, and it exploded with more energy in a split second than the sun releases in 30,000 years. This was the first time we had ever caught an FRB in the act, in our own cosmic backyard. And the answer was not aliens. It was a dead star. At that moment, many researchers breathed a sigh of relief, and also a sigh of disappointment, because a dead star is a boring answer. But the data said, nature did this. Yet even here, the story refuses to be simple. That Magnetar produced only a fraction of the energy of the distant bursts, which means the distant ones might be made by something even more extreme. Something we have not seen yet. Something our physics can barely describe. So here we are, 50 years after the first hints appeared in our data. 50 years of listening. And we still cannot say with certainty what is talking to us. But maybe the question isn't what's out there. Maybe the question is why we can't hear it. Because here's the part that should genuinely unsettle you. We are surrounded by a universe that is screaming, and we are nearly deaf to it. The bursts are hitting Earth constantly. Most pass right through our instruments unnoticed. We only catch the ones that happen to fire while we happen to be looking. It's like standing in a pitch-black forest, blindfolded, and guessing how many birds are around you by the ones that land on your hand. That is our view of the universe. A hand, a few birds, a guess. Now, let me take you back to the year 1967. A young astronomer in Cambridge, England, detects a signal pulsing every 1.337 seconds. The graduate student who found it, Jocelyn Bell, jokingly called it LGM1, Little Green Men. The team almost kept it secret, terrified it was aliens. It turned out to be a pulsar, a spinning neutron star. Nature, once again, history was repeating itself in real time, and no one noticed. Fast radio bursts are doing to us exactly what pulsars did in 1967. They are showing us that the universe is full of mechanisms we haven't discovered yet. And the worst part? We're not even sure how many of them we're missing. Let me take you into the room where this is really happening. It's night at a radio observatory. The telescope dish is 100 meters wide, pointed at the void. Inside, a computer is scanning the sky, listening on a frequency no human ear can hear. The scientist on duty is watching a screen of noise. Static mostly. Nothing. And then, without warning, a line spikes across the display. It climbs, peaks, and vanishes, all in 5 milliseconds. The scientist has no time to react. It's over before the eye can follow. That's how fast it happens. And that's how easy it is to miss. This moment has been playing out on telescopes around the world for decades. Arecibo, Parkes, CHIME, the VLA, and soon, the Square Kilometer Array. Each one built to hear more. Each one discovering how much we still don't know. And behind all of this listening, there's a strange truth we tend to forget. Every fast radio burst we detect left its source billions of years ago, before there were continents as we know them, before humans existed. The light that arrives tonight began its journey when our planet was barely formed. We are not listening to the present. We are listening to the past. And by the time these messages reach us, the source may no longer exist. That's the thing about the universe. By the time you hear it, it's already history. So, are the signals aliens? The honest answer is, we don't know, but we have a good guess. The most likely explanation is a magnetar, a collapsed star with a magnetic field beyond imagining. But most likely is not certain, and the mystery is far from closed. There's a reason astronomers are careful when they talk about this. In 1967, we laughed at the idea of little green men, and the universe proved to be stranger than any of us expected. It didn't need aliens to be extraordinary. It just needed physics we hadn't met yet. And that's the real message of the fast radio burst. Not aliens, not invasion, something quieter and more profound. A reminder that we are sitting in the middle of a universe we barely understand. For 50 years, we've been listening, and the signal has never stopped asking the same question. Who are you? Where are you from? And why are you here? Except now, you know the twist. The questions aren't coming from the bursts. They're coming from us. Every telescope we build is a question we're asking the universe. Every pulse is a doorway we're still too blind to open. And the doorway only opens when we're willing to admit how much we don't know. So the next time you're under a dark sky, remember, above you, in that silence, there are signals arriving right now. Messages that have crossed billions of years and billions of light years to reach this exact spot. And you can't hear them. You were never meant to. But that doesn't mean they aren't there. Every time we upgrade our ears, the universe gets louder. And every time it gets louder, we realize how quiet we've been keeping it. 50 years of secret signals. And we're only just beginning to listen. If this video made you look up a little differently, consider subscribing. Void and Voltage is about the space and the technology that shape your world, and the mysteries hiding between them. New videos every week. Thank you for watching.